Okay, let's move on to the list interface. So the list interface is a sub-interface of the collection interface. So that means collection inherits its methods. Then we have to look at the list. Characteristics and unique methods. The list interface extends collection. The list interface allows you to store duplicate items. All elements are stored in a linear fashion. Storage elements can be accessed by an index in a program. That means it actually has an index to operate on. So learning about arrays, we know that the first element has index 0. Instances of the list interface store items in sorted order. That means the order in which we store and the order in which we retrieve. It's the same. List inherits all the methods from collection, but also adds some. A unique method that operates on a collection based on its element index. The add method starts by adding an index, and then followed by his element. Inserts the element into a similarly specified position. The handle method inserts a collection at a specified location. The get method queries against the index. Remove removes the element at this index. Well then set is to modify. Index off returns the position of the first occurrence. Last index off is the position of the last occurrence. So let's go through a case study. To familiarize you with some of the core methods, let everyone familiarize themselves with it. So at this time we receive the type. Should be changed to list. So first of all, the first point, we can use its unique methods. The list interface extends the collection interface. So it has some special methods. Specify the location of the inserted element. I can index by an index. To query for an element. Set modifies an element by specifying its index position. So let's go ahead and I'm going to show the 3 core methods. In this case, you can insert an element into the 0 index. For example, call Jongsan. Of course, you can also use the normal method is a method that inherits from collection. Zhongsan Li Si. Then Wangwu and Zhaoliu. Let's go and execute it. Now that this collection has actually permutations and combinations, you print this example, there's actually a default override of this toString method. If I specify the location of the insertion of an element, so this position is Tianqi. Zhongsan is squeezing back to execute. The 0 index is here, so if I add another element, for example, Zhou Xingxing, shouldn't it be in Zhongsan's position? Insert this element at this position. Let me, Zhongsan, Li Si, Wang Wu, Zhao Liu, be in the back row. Then we have to query very easy. This is the value at index 0. This query is based on the index. This is a method not available in the collection interface. Modifying the element. Let's say I change Zhuingxing to Zhou Xingqi. And then we print it out again. Execute. So here are some of the list's special methods. It mainly provides index-related operations. That's all about the list interface. Okay, so let's move on to ArrayList. A list is not the same as list and collection. It is the implementation class. The two just now are a super interface and a sub-interface. ArrayList is an implementation of list's interface. And since it's an implementation, so we can manipulate it. When we were demonstrating, it's all an ArrayList operation. So for our collections, we need to think of it as an array of variable length. So for the ArrayList, well, look at this. Its insertion procedure. This is just like a native array. So copy R1 into R2 and add the new elements to R2. Is what we call inserting an element itself. Is the length of this array immutable? When we talked about array, we said that the length of an array is immutable. So when we add an element, we're not extending the length of the array. It creates a new array. Let's say we have R1 to R2. Then R2 is a new array. And in that new array, we can copy some elements of the old array, and then put the new element at the end. This is the process of inserting elements. At this point we can get the length of the list. We can remove. This remove is the position where the 3 index can be removed. We can also modify and so on. These operations. It's not also very convenient. Then you can just repeat this example code. After adding, we now continue to see. We now want to see the length, that is, the number of elements. And then go to print. Let's say we want to delete A or get A, the first element or the second element. This is the second. The first one is 0. Okay? Then we can remove an element. We remove the Wangwu. Okay, so after we've removed it, we'll print out all the remaining elements to execute. So we can query. There are still some fetches to be seen. You see the number of elements is 4 at the beginning. The second element is Li-Si. We're left with Zhongsan, Li-Si and Zhaoliu. Then we can modify one of them. Change it to Zhongsanfeng. After the change, we print the list. This time we execute. Zhongsan becomes Zhongsanfeng. We see that this deletion, replacement, that is to say, modification, it's all possible. Note the element with index 1 is the second element. It's the same as an array. The position of the index is from 0 to last. Then we must pay attention to the range. Otherwise there will be a corner mark overrun. So let's say I set an index of 3. Come this time we execute. That's why there's an exception. Just pay attention to this. The minimum index is 0. The maximum index is size 1. So it's more than that. There will be an index out of bounds exception. So much for the ArrayList operation. Learning about linked list is also a major implementation of the list interface. It has a side-by-side relationship with ArrayList. What's the difference between it and ArrayList? First of all, their underlying data structure is different. Linked list is a bidirectional circular list. So if we insert a new element, we only need to change the references between the references between the elements. The same is true for deleting a node. So to make it easier for you to read, look at this diagram. When we add an element, is to change the reference relationship. For example, element 1 and element 2. So when we add a new element, then this time, all we need to do is have element 1 to point to the new element. Then the new element points to element 2. Let's change the points to relationship between elements 1 and 2. The same goes for deleting elements. Deleting one of the elements, for example, removes element 3. We just need to make element 1 to point to element 3. Just point to element 2. So they're adding and removing elements is faster than ArrayList. But there's an advantage and a disadvantage. Something like ArrayList has the advantage of being fast. The disadvantage of linked list is that the query is slow. So let's take a look at some of its unique methods. Let's say we add some elements. We can print and then add the elements. Create a package. We can add an element like Zhongsan. Li Si, Wang Wu. After adding for elements, okay, after we're done adding, we can print the list. Execute. So first we add the first element. Is it the first one we put in? The last one goes to the last one. The same goes for deletion. At this point we can delete before and after. Also by the position of the index. So much for linked list.